Good morning. Thank you very much, Hugo. I'm very grateful to be invited to the meeting today, and hope that I could share a little bit about what Fluke is doing and that it might be interesting to the group. So, again, originally I was asked to talk about something that we had a QR code that is kind of on topic for today, but I thought I would also talk a little bit about the past, present, and future of some of these activities that Fluke is working with to realize a digital SI as well. And let me share my screen. Okay, there we go. And I think if everybody should be able to see my screen, so I'll go to my next one. And again, a little bit of background about this. Fluke has definitely been very interested and involved with all of the activities that the NMIs around the world are doing to realize or develop this from a dream into a reality about the digital SI. So we've attended the BIPM workshop on the International System of Units and Fair Digital Data, as well as the DCC conference that was sponsored by PTV. We're also an active participant in the NCSLI 141 committee, and I'll talk a little bit about that at the end because I think that everybody is welcome to attend that committee, and I think that is on metrology information infrastructure that started before the concept of digital SI even had started as well, and we also have been meeting with NIST on this subject to do some brainstorming back and forth with some of the team on this process as well. So we definitely want to be involved, and we see that this is very much a part of the future for industrial laboratories as well as the national metrology institutes too. So a little bit more about Fluke and where we all started. All of this started with an effort to standardize Fluke's calibration certificates. Before I arrived at Fluke had also acquired a couple of other companies, the Datron WaveTech, Hart Scientific, and Ruska, and DH Instruments. So they were still all in a flux where they really haven't standardized our process yet. And one of the things we wanted to do was to standardize our calibration certificate, its format and content, because we felt that was the biggest win for our customers to be able to read and interpret a certificate from any of our locations and be able to go to the same page and be able to see the same kind of information. And because in metrology, the product that we provide to our customers is that calibration data. And very quickly, I'll show you just a quick picture of what that looks like. This is a kind of an example of a calibration certificate that we provide. This is just page one of what our certificates look like, and it should look that way, hopefully anywhere that Fluke produces a certificate. And I wanted to kind of focus on the bottom part, the information on this bottom part of the certificate. So at the bottom of the data, page one of the calibration data, we have a QR code. We have a calibration label. We have an authorizing signature spot. We have our address, our page number and number of pages, and the revision date of the template, for our calibration certificate, of course. So a little bit about the QR code and what we've done. And again, we've been using the QR code on our calibration certificate for approximately 10 years now. On it, people like it, but we haven't gotten a lot of feedback from it yet either. But again, we were trying to do this for the benefit of the customers long before there was consideration of a digital SI. But currently, the information that our QR code has is we have the Fluke laboratory code of where the work was performed, whether it was in our Fluke Park primary electrical standards laboratory, in our electrical calibration factory in Everett, or if it's in American Fork, Utah, or temperature laboratory. The calibration certificate number is on that because that's something that's easily traceable back to the information. It also has the date of calibration that it was performed, and it has the serial number of the device under test out of that. Now, that's not a lot of information necessarily on the QR code, but our goal in that was to not have too much information because we did not want to make the QR code so dense that it was difficult for a camera 10 years ago to be able to interpret. I think we could make the code a lot more dense now because the resolution of cameras is much, much better too. And again, back in 2011, 2012, there was still a lot of paperwork in calibration certificates. So our goal was that we should be able to have the original printed certificate, and someone could make a photocopy of that, and someone could make a photocopy of that, and somebody could take and make a photocopy of the third device. So in other words, 3 iterations of photocopies away from the original certificate, and the QR code must still be able to be readable. That we felt that was a pretty important part because we still are in this transition from a paper type of a system around the world for traceability to this new digital age. I will say, again, it's not perfect security, as I believe Jean had mentioned, that yes, you can still falsify QR codes, but we found that it's a little bit better security than what was out there now. We actually had discovered a couple of incidents where the QR code helped us to identify an improper alteration to an original calibration certificate. In other words, we found somebody who was photoshopping the date on their calibration certificate, but it didn't match the date on the QR code because they hadn't considered that. So, and as we go forward, one of the things I always ask our customers, and I'm very interested from this group as well, is what other information should we be putting into this QR code to make this more helpful to our customers? So, and then just a little bit of extra information about some of the things at the bottom of the certificate that might be of interest or things that we need to think about. We included a special paper where the label is embedded into page 1 of the calibration certificate so that it has a calibration label that can be peeled off of the certificate and placed on an instrument if the customer wants, or they could leave it right there on the certificate because some customers have their own calibration due dates and labeling in their laboratories that they want to use, so they may want to keep that just in the calibration certificate. And we also found that no matter where we decide to place a calibration label for the customer, we're usually wrong because they may put it in a rack configuration, so the label may not be visible, or everybody has where they would like to place the calibration label, so we allow the customer to do what they want to do on that. We do have a signature spot, and that spot can be either hand signed on the calibration cert, or we can use electronic signatures for a process. And again, most of our electronic signatures are used in high volume processes or highly automated processes, where in some of our electronic calibrations, the skill of the technician is almost irrelevant because we have, to use a Japanese term, pokio, which means error-proof the process so much that there is no skill requirements from the operator. All they're doing is moving it from station to station because we calibrate all the way to the ends of the cable, so they can't even make an error with connecting bad cables because that's a part of the calibration system, and it's a part of our process metrology that we do every day. So again, we have the ability to have confidence in our electronic certificate process. And again, as we go forward, though, I think that there will be a lot more discussion about electronic certificates and validity of that. If anybody's familiar, probably the most rigorous requirements around electronic signatures are from the United States Food and Drug Administration, the FDA. They have a lot of information or requirements around what needs to be in an electronic signature. So one of the things that we're doing today, so this is now we move from the past to some of the things in the present. We are doing an experiment right now. So when you send an item to Fluke Park Laboratories in Everett, where our headquarters building is at, our customers now can also, if they request, they can receive an XML version of the calibration certificate. So, so that would include things that come to our primary standards laboratory, newly manufactured products such as our 5500 series and 5700 series of electrical calibrators, our pressure controllers, our dry well calibrators, our liquid temperature baths, and anything that comes back for service. They're all within the scope that's providing the XML version of this certificate right now. And again, I'll pop over. So this is an example of what that looks like, and I'll jump over and show you a little bit more detail about this. So this would be page one of the particular certificate, which is a 5522 calibrator, and it is an 8-page calibration certificate. So this is the first page of the data. This is, and now we're starting to go into the actual measurement data for the 90-day specifications, the maximum permissible error. And you can see there's a lot of information in this certificate. So I could pop over to the, now I got to get over to the right file, this is what the XML file that the customer will get sent electronically to them as well. So you can see that there's a lot of information. I'll just go down towards the bottom here. So you can see test certificate results minus 100 degrees Celsius, it looks like, and the nominal value and the measurement result and the measurement result units and the error and the uncertainty and the specifications and flags of whether it's in the specification or not. So you can see that, you know, there's a lot of information here, and it gives the end customer the ability to pull this data electronically into their system if they want to make kind of, if you will, an API to be able to convert the data and suck it into their system as well. So going back to this, yeah, fairly quick process. So a few thoughts about what we're trying to do in the future, since the subject of this group is cloud computing as well, is that Fluke is in the process of migrating towards cloud applications for everything that we do. We definitely see that is the future of metrology. So whether we're storing and delivering calibration certificates for our customers, you have it through a customer portal. We also have another product that we're developing that it's called Qubit, and it's a cloud-based application that the goal of Qubit is to be able to give to anybody for free the product specifications for any piece of test and measurement equipment that's ever been manufactured in the entire world. We estimate that there's between 3 and 4 million of test instruments around the world. We currently have a database that I believe that is loaded in approximately about 1 million of them right now. So, and it continues to grow. So we want that because we find that when you're performing calibrations, the first thing you need to understand is the product specifications. What are we trying to test for a product, and what is its expected performance as well. So it always starts with the product specifications. And we're also even doing some work, and we're not there yet, but we're still a few years out on this, but even making cloud-based test executives where you could connect to the cloud, to your device under test, and perform the calibration. The end goal is that we can do calibrations in situ at the customer's location, maybe deliver the reference standards to the customer, connect it up to a cloud-based application, and then perform the calibration. That is a goal or a dream of what we're looking at doing. So as we go into the future, I envision that all of our calibration certificates will be stored in an XML format, and then if we have them in a nice XML format, we should be able to, if somebody wants a viewable calibration certificate, a more traditional, if you will, paper printed copy or PDF copy type calibration certificate, then we can easily be able to have a tool that will convert the XML data back into a certificate that looks like that. But at the same time, as the digital calibration certificate standards start to become fleshed out and standardized, if we started our raw XML process, we should be able to build a converter that will be able to deliver calibration certificates to a DCC standard when we finally develop that standard as well. So yeah, what our real goal too is that every calibration data set that is produced by Fluke will be available to a customer through the calibration portal, starting with the manufacturing calibration data. So that you should be, for customers who send products back to Fluke, they will be able to see cradle to grave calibration histories that electronically maintained, so that they don't have to worry about that. Because I'll say right now that one of our biggest points of pain within our organization is that the customers will lose a paper calibration certificate and then they'll ask us for a reprint, and we really don't like doing that, but we haven't given them a better solution that they could serve themselves. I do see a question. I'll hold off on that toward the end as well. Again, but just to say that this, where we're at right now, we're very much in the infancy of the digital SI as well. So these are beginning steps. We're certainly not to an end. We have lots of improvements that we anticipate doing. We're very interested in hearing what is important to other people, and input from people like yourselves is always fascinating and important to us. And at the same time, we're very interested in participating in standards development. For example, again, I'm a representative on the board of directors through NCSL International, and we are a liaison organization to ISO Casco, so that we can help participate in that process as well. And our goal, what we hope to achieve, is to be the gold standard for industrial certificates of calibration. So I did want to again make one more pitch for NCSL International and their 141 committee, because I think they're doing some interesting things that this group may want to consider as well. One of the things that that committee is working on is what is referred to as the Metrology Taxonomy, so that they can understand the order and ranking and families of different measurements. So we can, because in order to have a DCC, we're going to have an agreed upon taxonomy and hierarchy of all measurements and how they relate to each other as well. And another issue that is recently came up is that a digital calibration certificate is great, but machines are not that smart just yet. We need to make them smarter with our AI and teach them. And if it sees something like a degree symbol on in an XML file, how does it know which degree we're talking about? Is it a temperature measurement, or is it an electrical phase measurement? The machine doesn't know. And that information is not readily available in the DCC. And so there's been some discussion about another layer underneath to enable the DCC that's called the M layer, that will help define those ideas and terms to really clarify how to interpret the data that is within the DCC. So again, just and that, by the way, the 141 committee does meet every they do weekly meetings on teleconference, so anybody's welcome to jump into that as well. So and with that, I think we're ready for some questions. I do see two questions I can get. I'll start with, which is one from Francisco. And the question was, is the alteration of QR codes a major problem? How can we deal with this problem? And again, if somebody wants to commit a crime, it's very hard to stop them. It's always a cat and mouse game, in this process. But it's been our experiences. We've had people when they've tried to alter things on a calibration certificate. They'll alter the written documents. Well, we have not observed anybody to have altered our QR codes yet. Now, I do think that it's very much a possibility, but I will say that if we consider, when we look at Fluke, when we look at risk, when we do risk analysis, we look at impact of what happens if this should happen, and also the probability of occurrence. And right now, the probability of occurrence is very, very, very low on that. So the overall risk number it turns out to be a small number on that now. It is finite. It does exist, but it's a pretty low risk what we've seen at this point. And the next one, comment or question from Alexander was that a very important feature of DCC is that it be machine readable. Are you doing some tests in this way? And yes, and that's why we're, if we provide our data in an XML format, that should certainly be machine readable. For that process, anybody should be able to pull up and draw into their system XML data. So that's a pretty standard and accepted format. But I think the key will be, again, making the translation tool, when we have defined fields of the DCC, to say, here's where our data exists in the Fluke system, to the output that they want in the DCC. That, I think, that's going to be the biggest part of it. And then Mariano, thank you very, very, very much. And then Salvador, I'm glad to see you're attending today. And his question is how can SIM take more advantage of your experience in the topics, the NCSLI committee, and something else? Again, Fluke would be very honored to continue to interface with this topic. I would really, one of the things, if you are interested as well, that we're doing some really good things, and one of my associates, Mr. Mike Brown, is developing some very interesting things that I think fit nicely into this subject. For example, again, an international, or a global measurement model for measurement, where we could apply measurements back to the general case for any measurement, and we could share what we're doing and thinking about in that. He's doing some work with IMECO in the CFM conference to present some papers on that. Again, I could put in here after my presentation, the information to contact and get in hold to join the NCSL 141 committee. They would love your involvement. We've got some people from the U.S. involved. From New Zealand is now attending that meeting. So if New Zealand can make it, they wake up in the morning and come to the meeting. Hopefully everybody else can as well. And I believe we're getting NRC Canada involved with that too. So I think, again, please let me know. I'm happy to have continued discussions about how we can help and support the SIM, with this process. And I see from Roberto Benitez, it's saying, greetings from Monterey. That's wonderful. And again, Salvador, yes, and hopefully we can catch up. I'd love to chat with you. We haven't had a chance to talk in way too long. And then, yeah, how does Fluke's XML schema compare to PTB's? We haven't done a full side-by-side comparison because we feel like it's not quite the PTB one is still being developed. So I think, but again, as that becomes a standard, that's I think we're going to make the translators to make sure that our XML schema is exactly what the standards XML schema is. And Chuck Ehrlich, yes, I saw you, Chuck, online. It's great to see you again as well. Thanks, Jeff. You briefly mentioned traceability. Does Fluke envision incorporating all of its information into the DCCs that would naturally allow for demonstrating traceability to one instrument standard to another? Absolutely. And I think that may be a combination of the DCC and the M layer that we had talked about. But, I had this dream, and it was almost 20 years ago that I first was seeing this, and that was when the KCDB was first published, where the KCDB is comparing and demonstrating traceability between NMIs for NMI to NMIs. And I would love to see a scheme where an industrial, the end user, say a factory in Vienna, can buy a piece of equipment that was manufactured in Korea and calibrated by an accredited laboratory in Korea that could relate the traceability to possibly to their NMI, where the Korean NMI would connect into BEV, the NMI of Austria, and connect down to the end user laboratory. So you can see the entire global path of traceability from where the calibrations were performed to where the end user lies. That's my dream, and I think that the KCDB is part of that. I hope that this is another part of that, and this may be the technology that enables that, Chuck. And if you want to come on and talk about that, I think we have, depending on the moderator, Mr. Gasca, if he has time, you could if you got more thoughts on that.
Thank you very much, Jeff. I think we still have a couple of minutes. If any other comment or question, I have a couple, but I would prefer to hear some others. if that is not the case, yeah, Jeff, yes. Do you think it's possible to share an example of the XML schema from Fluke with no commitments of nothing?
I will email that. I emailed my presentation this morning. I'll send an email to that. And I do see Chuck coming on screen, so I think he has a question or comment.
Oh, yes, go ahead. Yes, Charles? Or I don't see another question.
Yeah,
go ahead.
Okay, all right. Well, thanks, Jeff. Thanks for the invitation. Yeah, I think that it could be very useful in digital calibration certificates to have what you're talking about and to be able to, at the click of a button, to show the whole traceability chain, all the different aspects, the different contributions to uncertainties, to all the influence factor, all that stuff. If it was all available there, it could be very useful to people to see just where the traceability is coming from and what standards were involved. And of course, traceability is of measurement results, but I guess that can be extrapolated to measurement results coming from an individual instrument.
So, at least to that point, yes, absolutely. And I think that what Gene was talking about in the we may need blockchain to secure that chain of traceability, in the process as well. And then maybe when the end user performs measurements, if they're a testing laboratory, then maybe they can add to that blockchain to the end product that they test.
Right, exactly. And what this all means in the context of the 9th SI brochure, also something to bring into the mix. So yeah, so thanks, Jeff. Really appreciate it. Look forward to continuing the discussion sometime.
Great seeing you, Chuck.
You too, thanks.
Okay, Hugo, any other
Thank you,
questions?
Charles, for the question. Yeah, well, I don't have more questions like that. Just to mention two points that I think that we should focus on the QR code just to be the ID of the certificate or the instrument, and then connect to a system, and from there we have the date of the last calibration and certificates and everything, or the history, as you mentioned. That could help not to put too much information, also because there's a kind of a potential risk of disclosing information unnoticed if we put more information that should not be available otherwise. And I agree also, the other point that I want to mention, that I agree with you, and these NCSLI meetings, I has pointed out, and also to PTV, that I feel that we are missing we need to push harder on the taxonomies of the measurements, and the current PTV schema focus just on quantities, not on the measurements by themselves. So it seems like there are some holes to fill there. So with that said, I want to thank you very much for your presentation. Very, very interesting. And also, as you mentioned, more than 10 or 20 years doing this. So it's almost like very, very tested, and not like improvising something, right? So we should look at this and learn from this. Thank you very much, Jeff.
Thank you, Hugo. Thank you for inviting me today.